Our next technique in factoring, when you see the problem initially, it's going to look unique in that we're missing that middle term. But when you think back to when we were distributing, remember what caused that middle term was two different signs. This one we had those numbers cancel out in the middle. This is still going to factor as my product of binomials. X and x is still going to give me an x squared. But remember what caused that middle term to cancel was the positive, negative, or negative and positive. It doesn't matter what order you put those in. But remember what we called this was? This was when we had our difference of two squares. And when we look at this, there it is. 9 is that squared. X is a square. 1x squared if we want to look at it that way. It's the x plus 3, x minus 3. This was when we factored out. We got the x squared. Awesome. We had a negative 3x. We had a positive 3x. And that's what would get that middle term to cancel. 3 times negative 3. There's my negative 9. Everything is good. That gets that middle term to cancel. These are the ones that are going to be really quick and easy and we're going to love to see. And especially in our day 4, this is what's going to help us really burn through some of those other problems a lot quicker. 4x squared minus 25. Notice again, 4 is a square, it's 2 squared. 5 is a square, it's 5 squared. 25 is 5 squared. When we do our product of binomials, we aren't even going to have to use that whole AC method. 2x and 2x plus minus is what gets things to cancel. Plus 5 minus 5. And we can look at when we FOIL this, there's my 4x squared. There's my negative 10x. There's my positive 10x. There's my negative 25. And notice, that's get those two middle terms to cancel. Oh, positive times a negative is a negative 25, which it would need to be. And in fact, that's what gives us the next problem. We're going to see x squared plus 100. We see that being a square. Immediately we want to say x plus 10, x minus 10. But the problem is, while that would give us a 10x and a minus 10x that would cancel, the problem is that gives us a minus 100. Intuitively, well, why not just make them both a plus then? If we make them both a plus, that would give us a positive 100. But the problem is that would give us a plus 10x and a plus 10x. They aren't going to cancel. We'd end up with a plus 20x. What would happen here? This is what's called a sum of two squares. Remember, difference means subtraction. Sum means square, to add things up. And what happens is when we have a sum of squares doesn't factor. Remember we called it prime before? Those are actually good for us. That means less work. But it's very important that we recognize when it's a minus, absolutely, it factors with a plus minus. That's what got it to cancel. But that's what forced that to be subtraction. When it's a sum, we need them both to be the same sign. Nothing's going to cancel. To kind of summarize everything, another problem, and again, all they're going to tell us is factor completely. Well, when we look at this, the way we can get an x to the fourth, remember, if I had x squared squared, power of a power, that was when I multiplied exponents by saying x squared and x squared. And if we even want to look at it as x squared times x squared when I'm trying to FOIL it, add my exponents, that's what gets me my x to the fourth. 16 is a square. Plus 4, minus 4. And again, it wouldn't matter what order you put those in, but we aren't done yet. Math Excel won't like this because we aren't factoring it completely yet. Here we have another difference of squares, x plus 2, x minus 2. Right? That's what's going to cancel out that middle term. That's what's going to give me an x squared, and it ends up being a minus 4. Over here, as tempting as we want to say, like x plus 2, x minus 2. Or we'd notice that would give us a negative 4. We'd want to say x plus 2, x plus 2. But remember that because this is a sum of squares, it's a no-go in the factoring. Here's my factoring completely. And this is an excellent problem. And then it really illustrates when I'm allowed to factor as a difference of squares because it's subtraction, I need the different signs to cancel. But when it's a sum, I need them to be the same sign. I won't get them to cancel. So for that reason, it doesn't factor.